In this video, I will show you how you can use a simple math calculation to calculate the height of a mid-span roof beam. And this would be a beam that would be supporting the roof rafters in a large building like this one here. And hopefully by the time you finish watching it, you will know how to do it. And I will have taken all of the mystery out of this particular process of extremely complicated construction that can often be made a little easier with a video. So let's go ahead and throw some roof rafters in there to give you an idea that the top of the beam is going to fit into the seat cut like this. We are not going to be using the bottom of the roof rafter, or should I say most of the time we're not going to be using the bottom of the roof rafter, because roof rafters are usually going to have seat cuts in them. And these seat cuts will need to be the same measurement, otherwise they will need to be adjusted. And you're going to be able to use the same process here to calculate the height of the roof ridge also. And I do believe I have other videos on that. Make sure you go to the website and check those out in the home building, framing, and roof framing sections at our website. So let's go ahead and draw a little triangle here. And you won't have to draw this. You will simply use the building plans or measure over when laying out the wall framing, the distance from here to here. And if you notice, this point here is the same part of the roof seat cut. So don't measure from this side to the other side, or from the inside of the wall to the inside of the post. This is going to be critical for calculating the height or the difference in the wall framing. Remember, this is the top of the exterior wall framing where the rafters are going to be sitting on. And this will be the difference from the top of the wall framing to the top of the beam. Now, the first thing we're going to need will be the roof pitch. In our example here, we're going to be using a 4 and a 12 roof pitch, or a 4:12 roof ratio. And this simply means that for every 12 inches or 1 foot that we go over, we're going to be adding 4 inches, working our way up with a 4:12 roof ratio. If I come in 2 feet or 24 inches, I should be up 8 inches. Come in 3 feet, I'm up a foot, and so on. And you can do this a variety of different ways, but we're going to have to convert this, or the measurement we're going to be using here, into a decimal that will convert the inches to feet. So let's go ahead and break out our calculator, and we can simply multiply 9 feet times 4 equals 36 inches. So we're going to be up 3 feet at this point here. 9 segments multiplied by 4 inches of rise per foot gives us 3 feet. So we can write this number down, 36 inches, and then add it to what we come up with here. So let's go ahead and take 10 and turn it into a decimal, 10¼ inches, and I'm going to divide that by 12. We have 12 inches in a foot, and that will convert this to a decimal, and we can use this decimal here. This represents the measurement in feet. So 10¼ inches will convert to 0.8541, and then we can simply multiply that number times the rise to give us 3.41 and the number that we can add to 3 feet. So this would be 39 inches, 0.416, or 3 foot 3 inches and 7/16 of an inch. Now let's go ahead and clear this, and let's just say that I converted this to our decimal, and I'm going to add this to this, making 9.8541. So here's the 9 feet. Here's the decimal that was converted from 10¼ inches. And I can simply multiply this times our rise to get 39.4164, or 3 foot 3 and 7/16 of an inch. And if you're working with a 5:12 roof pitch, you're going to use the 5. If you're working with a 7:12 roof pitch, you're going to use a 7. I would convert this to our decimal that would represent feet, and then multiply this number times 7 for a 7:12 roof pitch to get the difference between the top plate, top of the wall framing, and the top of the supporting rafter beam. So let's go ahead and throw some walls back in here. Remember, top of the wall framing, we go over level and then we come up. And this provides us with the top of the beam measurement. And then all we need to do is subtract the difference of the height of the beam to get the size of the post that we can install in our wall framing. And you can always use the same method here to calculate the rake wall, or the angled wall height that the bottom of the rafter will sit on top of. Now let's go ahead and wrap this video up by showing you the seat cut. Here we have a 3/4 inch notch in the seat cut, or the plumb cut of the rafter is going to be 3/4 of an inch. And we're going to have the same at the bottom. 3/4 inch notch here, 3/4 inch notch here. If I change those cuts, for example, if I was going to make this 1 inch, then I would need to adjust for the difference to calculate the overall height of the midspan support beam. And like I said earlier in the video, hopefully this makes sense. However, if it does not, if there's something in here that doesn't make sense, feel free to share that with us in the comment area, or let us know if you enjoy watching our videos. I get a lot of positive responses and never get tired of hearing how our videos help our viewers.